Hello, everyone, and welcome to this Lightbend webinar for February 6th, 2020, or 2020 rather, titled Akka Antipatterns Goodbye, 6 Features of Akka 2.6. My name is Oliver White, and joining me today as our special guest is my friend and Akka expert, Manuel Bernhardt. You may know Manuel from the conference circuit where he is a regular speaker, but he's also an engineer, author, and consultant with a keen interest in sharing the science of building and operating networked applications that can still run smoothly despite their distributed nature. While I introduce today's webinar, which should last about 45 minutes, including time for Q&A, I'd like to ask our audience a quick poll question about your current version of Akka. So if you haven't upgraded to Akka 2.6 yet, what's holding you back? So if you've ever worked with Akka actors in the past, you may have experienced some anti-patterns. One of the more common ones is, for example, sending a message to an actor that doesn't actually exist. Now, with the release of Akka 2.6, however, this sort of mistake and many other shortcomings of the classic Actor APIs have now been rendered pretty much impossible by design. And this is allowing new users to more easily embrace the actor model of Akka. So if you were totally unaware that Akka 2.6 is now out in the wild, despite all of our best marketing efforts, then you're in luck because Manuel knows all about Akka. So today we will be covering Akka 2.6 release highlights, including the new Actor APIs, also known as Akka Typed, the new Artery transport layer, which brings improved performance and stability to clusters, and a new default serialization mechanism based on Jackson. Then we'll look at 6 anti-patterns of Akka that are now history. Which anti-patterns in the Akka Classic version have been addressed by Akka 2.6, and how you can start making use of these new features. And also a final anti-pattern. Manuel will go into a little bit more detail about what he thinks may be one of the last remaining anti-patterns when using Akka, which comes down to not understanding your hardware. All right, thank you for your poll responses. Now, just for a little bit of housekeeping before we start, as always, today's webinar is made possible by Lightbend's hundreds of happy customers who get benefits like expert support, technology enhancements, and observability and monitoring tools from our subscription program. One of our happy clients is HPE, and they have many positions open for folks working with Akka, Scala, Logum, Spark, and Kubernetes on their InfoSite team. You can actually find out more about these open positions and other open positions with Lightbend customers, depending on the technologies that hopefully our listeners are using, on lightbend.com under the About tab. Today's webinar is being recorded, and it will be shared with you in the coming weeks. And if you have any questions for Manuel today, feel free to add them to the control panel under the Questions tab, and we'll see if we can get around to them in the Q&A part of today's session. If you're an existing Lightbend subscriber, then you know that you can always reach out directly to our expert engineers through the customer portal so that you can ask any technical questions, what-ifs, how-tos, and best practices. All right, that's all from me. Let's hand it over to Manuel. Hello, my friend. I'm very happy to welcome you to the Lightbend webinar program finally. It's been a while.
Yeah, we talked about this for some time now, yeah.
yeah. So I'm really happy that you're here today. Well, let's get into it.
Okay, thank you. All right, so I would like to talk about anti-patterns, or rather, what's left of them, or not much left of them in Akka 2.6. The reason for this is I gave a talk in 2017 called 8 Akka anti-patterns you'd better be aware of. And back then, the reason for giving the talk was that Akka is not a framework, it's a library, so you're freer to use it as you please, but that also means it's easier to make mistakes, to shoot yourselves in the foot. And over the years, I've been seeing a lot of Akka projects in very different companies, very different domains, industries. And so I've been collecting the sort of worst practices over time. These range from beginner mistakes to things that only show up in fairly large or advanced actor systems. And I started, writing about these and then giving this talk. And the nice thing here is that most of them have been addressed in Akka 2.6. Not all of them. There's some of them left. You can still, we'll talk about one of them. But most of them are gone now. I don't know if that's on purpose. I don't know if the Akka team has been sort of going through the list and sort of saying, okay, let's make this the past. So I don't know, but it's really the 2.6 release was really pleasant to look at, because a lot of things have really been improved in so many ways. So just a few words about myself. Yeah, my name is Manuel Bernhardt. I'm an independent consultant, and I'm a scuba diver when I'm not consulting. I'm helping companies to get started with reactive systems, or when they already have systems in production and there is issues, I also get calls from time to time. I'm also Lightband consulting and training partner, and I wrote a book on reactive web applications some time ago. So Akka 2.6, that's just one slide here to just summarize what the main things are. So this is a major release, and the previous release 2.5.0 was in April 2017. So it's been, I think, between the two releases there were 2.5 years of work. And I would say the main thing is that it introduces like a production-ready version of the Typed API, which we'll look into in detail. What is also important to say, I should say, is that it doesn't deprecate the classic one. So the Typed one is the one I would recommend if you're starting a new project with Akka. But if you already have an existing one, you can continue. Don't have to worry about that. And also there's a bridge between both APIs, so you could start adding more actors in your existing actor system with the Typed API, and then interface both things and slowly migrate to the Typed API if that's something you want to do. There is a new transport. It was already there in the 2.5 series, but now it's a default. It's the Artery, which replaces the Netty TCP transport, and this is built on top of Akka streams and brings stability and performance improvements. And then there's so many small improvements and fixes and things, and so I can't possibly list all of them, but there is a lot of work that went into this. So this is really quite nice. Okay, so let's get started. The way this is going to go is that for each anti-pattern, there's a quote. As you will notice, they will get darker and darker, but it's just the anti-pattern. And also, as said, these anti-patterns have been addressed, so don't worry too much. So let's start here. If you fail to plan, you're planning to fail. From Benjamin Franklin. I think this is a quite famous quote. So what our first anti-pattern I want to talk about is not defining a protocol. And what happens here is that it's easy to start building systems with Akka. You just write actors and design your actors, and then you start sending messages between actors and things start working. And it's quite easy to do this in this way without thinking too much about the protocol, about the messages themselves. But then as the systems grow, and if you're working a long time on the same system and there's many messages, if you're not thinking the protocol through, what can happen is that it's becoming hard to maintain these messages, especially if they have not been designed, if they've grown organically. So what does that mean? For example, what can happen is you're sending messages, some of them are commands, some of them are events, and then you might be tempted to reuse the same message, maybe the same event in more than one place. And then when the system has grown and you would like to separate out one part of the system, make it another service or something, and then you realize that your actors, everything is coupled, is interleaved together. One actor has to understand the protocol of 3 other actors or something like this. So, and that's then hard to work with. Then also the responsibilities that should be together in one actor, they could end up spread across several ones over time, and the protocol doesn't help that in any way or form. It's just because the protocol doesn't reflect the responsibilities. And then finally, one thing is that, and that I've seen a lot, is you keep on introducing new messages because it's easy to do that. But then maybe sometimes you would not have needed to introduce a new message. Maybe it would have been easier to extend an existing one or to architect the protocol a little differently. And here is where Akka Classic, where it's harder to do things with the Classic APIs, because the Classic API is very open. It's just messages, and you can send them to any actor. Doesn't matter which actor it is. It's a very open definition. But then when you want to change the protocols themselves, you know, it's up to you to check that you're not that you haven't forgotten anything, that you're not sending, you know, that you're sending the right events to the right actors, that you're still on track. There's a lot of testing involved, automated testing you should be writing if you, and there is no help from the compiler with this, you're on your own. And so the evolution in general, the maintainability on the long run is harder for these things. So how does that work in Akka 2.6? How can you not define a protocol in 2.6? Well, the thing is, you cannot not define a protocol. To the very least, what you have to do is to tell Akka what type of message the actor can handle. And if you're sending a message to which you want to reply, you have to specify what type of response you expect. So it's not like in Akka Classic where you can just reply to the sender blindly, whatever you want. No, the thing is that the message that you receive includes a definition of the type of response that you expect. So let's look into this in an example. So the way it works is you have to specify a marker trait or marker interface. That's sort of your top level message here. For example, I have an example where the actor is a configuration actor that holds some configuration, and the top level message or the top level marker interface is a configuration command. Now, when I define this actor now, here I'm using the object-oriented API of Akka Typed, and I have to extend this abstract behavior, and that takes a type parameter. And the type parameter is the top level message I want to give it, so it's the configuration command. I also, in the constructor, have a context. This is the object that helps me, for example, create new child actors. And this is also typed with this configuration command top level trait. And now if we look at, but this is just a trait, there's no message yet. So if we look at the concrete implementation, that would be, for example, the message retrieve configuration. If I want to get the configuration back for a merchant identifier, for example. And this one thing is it extends this marker trait, this configuration command. So that's checked, that has to be the case. And then the other thing is if I'm expecting a reply, I'm including in the message a reply to field of type actor reference. And this is not, if you're familiar with Akka Classic, this is not just an actor reference, it's a typed actor reference. And in the type here, it's the type of message that I expect to receive. And this is going to be a configuration response, which is to say that if I want to send anything to this actor ref here, to this the actor behind this actor ref, it has to be of type configuration response. Configuration response, again, here I defined it as a trait. And one example would be that the configuration has been found with the merchant configuration available. There could be more. There could be like a configuration not found in case I don't know this merchant ID. And this is sort of the definition of the response. So this is everything is very much more defined than with the Classic API, where I could just send anything really. There has to be more thought put into this, and even if you just put something very simple, you have to think of it at least a little bit. So what happens here? Well, first off, you cannot make the beginner mistake of sending messages to the wrong actor. I say this is a beginner mistake because typically after you've done it a few times, you sort of tend to understand what's going on. So what could happen is you send a message to the wrong actor, and maybe you notice a warning in the log, or maybe you don't. Nothing happens, or at least not what you would expect. This is not something you can do anymore, because now if you send a message to an actor, it has to be something that the actor understands. That's part of its protocol. Then the other thing is that the compiler is now there and helps check all of that. So the example where the case before where you want to evolve a protocol over time, that is something that is supported and that the compiler really helps you with. Now, if you decide to change the flow of messages, the compiler will help you to make sure you haven't forgotten any recipient or anything, or any strange case that you hadn't thought of. This is a big thing, I would say, in terms of maintainability. And then finally, I think the nicest thing is that you can infer the protocol flow by looking at the messages. And what I mean by this, I will show you an example, because I think this is really one of the nicest things is because now with the typed API, you cannot use an implicit sender anymore. You have to always specify the actor reference of an actor you want to reply to in the message itself. So let's look at an example here. I have a banking system, let's say, and I want to log in and make a transaction, just wire some money to someone else. So let's say I have one actor here, it's a banking actor. And if I want to do anything, the first thing I have to do is to log in. So the banking actor is an actor that understands the banking command type of messages. And there would be a login message where I have to send some credentials. And if everything goes well, if I send it the right credentials, then I am allowed to reply. And what I have to reply to is I have to reply to something that understands, or I have to reply using a login response. So what's a login response? Well, in the successful case, that would be authenticated. So I could be rejected as well or something like that, but let's look at the happy path here. So if I'm authenticated, this authenticated message contains a session. So what happens is that the banking actor has been able to authenticate me, it replies, but at the same time, or before that, it has created a new session actor just for me. That's my banking session here that is alive for some time. And the reference to this actor is passed, in fact, here in the reply. So this in this reply here, this actor ref points to this actor, which understands messages of type session command. And one of them is create transaction message, where I have to specify a transaction that I want to do, and then I can create my transaction. Here again, I could have specified another reply, which I haven't done in the example now, but you get the idea. And the nice thing is, from just by looking at this definition, it's perfectly clear that I first have to log in order to get a response where I can get the session, and only then with the session reference can I send messages to the session actor and do things like create transaction. I don't actually need this whole graph here. If I just look at the code, I cannot even write code that will compile if I'm not following these 3 steps. I think this is really one of the nicest things in Akka Typed. And once you get the hang of that, it becomes very natural to write things in this way. Okay, so that was our first case. I think it's one of the really strongest things in Akka 2.6, the typed API. So I definitely encourage you to take a deeper look at it. Now for the second anti-pattern. Time is a storm in which we are all lost. William Carlos Williams. And that anti-pattern is race conditions. And what do I mean by race conditions? Well, in the actor model, the nice thing about that is that messages are handled one after the other. That's one of the main points for the actor model, is to have a concurrency model that's easier to understand than threads and logs and mutex and all of these things. So the point is that inside of an actor, it's safe to use mutable state, because it's the actor that owns the state. There's only going to be one thing happening at the time, because there is a guarantee that one message will be processed after the other, unless you do the following, which you can do in Akka Classic. So I've got this transaction manager, which holds the very important list of transactions, and that's a mutable list here. I can receive a command process transaction, and what I'm doing here is I'm going to hand this over to another actor, the processor, and I'm going to use the ask pattern here. So this question mark here stands for ask, and I'm going to tell that thing, please process the transaction, and this returns a future of processing response or a completion state. So this is an asynchronous computation. And then while this runs, of course, my actor will continue receiving other messages, other processing transaction messages, possibly. And here I'm doing something really dangerous that I shouldn't do. This code is, don't do that at home. This is not how you should do things, because what I'm doing, I'm closing over my mutable state here. So what could happen is that I'm waiting for a reply, but then at the same time, I've continued processing, and I basically have the situation where the actor here is no longer in control of the state. The state could be changed here. This could be run in another thread outside of the control of the actor, and then I'm running a, in a scenario, in worst case, I could be losing a transaction, or I could be running things out of order, or this is really something you don't want to do, because that's gonna be a problem. So the problem really is that I'm mixing asynchronous constructs, like a future here, inside of the actor, and that's error prone. And I've seen, many times I've seen even experienced developers do that mistake. And then, of course, the recommended way to do this is to use the ask pattern in combination with the pipe pattern. The pipe pattern is just a way to turn a future into a message. But then maybe sometimes people don't know about it, or they forget about it. Yeah, that is still around. So how is this something that could, how can you do that in Akka 2.6, misusing the ask pattern with futures? You can't do that anymore, because the API has changed. Here is the same example, but now with the Typed API. And now I'm using this context.ask, where I'm giving the reference to the processor I want to ask. I give the message that I want to ask here, this process message. And now what I have to do in here is I'm getting the results from the asynchronous processing, and I turn that into a message. And what will happen is this message here that I've transformed based on the response of the asynchronous computation will be turned into a message that is sent back to the actor. So I have to handle it in my receive. Then it's again the actor that is in charge of mutating the state. So it's the actor that can safely change its state. And so I'm safe again. I can this is actually the pipe pattern inside of the same signature, so that it's a mashup. And this is, I think, is very nice, because this is something I've really seen quite often, so that's handled now. Now there is one thing you could still be doing, is you could, if you really want to shoot yourselves in the foot, you could instead of returning a message here, you could also add a side effect in that asynchronous thing, but it's not natural. It's not as natural as what we've seen here, where you would do that. That comes more naturally. I think the intent here is quite clear. If you look at the signature of this method, you see very clearly you should be replying with a message of the protocol of the actor. So this is a very nice way of solving things, I would say. All right. Our next anti-pattern. Some men aren't looking for anything logical like money. They can't be bought, bullied, reasoned, or negotiated with. Some men just want to watch the world burn. I really love this quote. It's from Alfred in Batman the Dark Knight. Very nice movie. And this anti-pattern is about blocking, which really is quite a problem. And still in 2020, it's still a problem. So how can this happen? Well, one way this can happen is if you're calling a synchronous API inside of your actor, and that blocks the thread. Or that's worse actually, is you call an API that you trust, it's something asynchronous, you're doing everything right, you're using the pipe pattern, etc., etc. But behind the scenes, this asynchronous API, in fact, is blocking somewhere in a library down the call stack trace. This is really not obvious to find out that this happens. Or you can be blocking on purpose, like you could be, if you're using Scala futures, using await.result, don't do that. Or you use just putting a thread.sleep in there for some reason, that I've seen a lot actually, thread.sleep. And that's not good. And why is that not good? And in order to understand why it's not good, let's look at how Akka is ticking. So I've been drawing here with my nice drawing skills, so to speak. So what we've got here is we have actors, and each actor has a bunch of messages lined up, sort of little queues here. And then on the other side, I've got a thread pool with threads in there. These little things are threads. And in the middle, I have this centerpiece, this very important component called the dispatcher, which does all of the magic. So what happens is, in order for Akka to do work, there is a thread that's going to be handed over by the dispatcher to an actor in order for the actor to be able to do work for a number of messages. So example here, during 2 messages in this example, it's called the batch size, by the way. By default, it's 5, I think. This actor is allowed to process messages. And then after it's done processing these 2 messages, the dispatcher will hand over the thread to another actor, so it can also do its work, etc., etc. Then maybe another thread comes back in and is handed over to the first actor to process more messages, and so on and so forth. And that works really well, unless the actors don't release the threads. So if you're blocking, what will happen is that slowly more and more threads will be used of your thread pool, and eventually you're running out of thread. Like all the threads will be blocked, waiting for something to happen, and then that's not good. Then you end up with a system that behaves in very funny ways, and it's really hard to explain. If you look at the logs, you don't see any error, and if you're not aware of the problem, that can be quite tricky to debug. Yeah, that's one thing you don't want to do. So how can you bring down Akka 2.6 by blocking in this way? The thing is, you can't. I mean, at least you can't bring down all of Akka. So what happens is there is a new internal dispatcher for all of Akka's internal mechanisms. And if you block, you can still starve your own actors, your own system, your own application, but then all the mechanisms that Akka relies on, like for example, if you're using Akka cluster, you would have a failure detector that sends messages to see if nodes are alive. That thing will continue ticking, even if your own application doesn't work. So not all is lost, so to speak. There are cases where you still may want to block or need to block. For example, if you're reading data off of a magnetic tape, if you need to do that for some reason or another. I don't know why you would want to do that, but that happens, it's very reasonable to assume that that's a blocking operation that may not have an asynchronous API. And for this, you could define a separate dispatcher in configuration, and you limit the size of the thread pool. So you don't give it an infinite amount of threads. You just set a fixed size here. And then when you're creating the actors that are potentially blocking, you can select, this is the typed API where you spawn actors to create a child actor, and using this dispatcher selector from config in order to retrieve the dispatcher. You can also do that in configuration for a certain actor path. This is just one of the ways to do it. So this is one thing to consider carefully. If you know you have to do some blocking things, just put it in a separate dispatcher and have it, be taken care of there. All right, our next anti-pattern. This is the way the world ends, not with a bang, but with a whimper. That's from T.S. Eliot. And this anti-pattern is about using Java serialization. And how could this happen? Well, this was very easy to achieve. You just had to leave the default on and bluntly ignore all the warning messages in the logs. Or what you could also do alternatively is write for your logging framework, write a little extension that filters these messages out. I've also seen that happen. So if you just close your eyes, you can just use that. And the problem here is that this is affecting both serialization of messages inside of a cluster if you're using Akka cluster, or for persistence, events, and snapshots, these things. And the problem is, okay, first of all, Java serialization is not the fastest, so you're paying the price in terms of performance, but also, and more importantly, in terms of protocol evolution across the wire, there is no really good way to do that with Java serialization, or it's clunky at best. And then for persistence, it's the same game. Your serialized messages, if you're serializing things, and you change the definition, but for some reason, one client of mine, they called me and they had a problem where they rolled out a new version, then they had a bug in the new version, so they had to roll back. But in the meanwhile, journal events had been persisted with the new version of the messages, which the old version couldn't understand. And so just the actors would be crashing in a loop. And up until that day, the team had not realized that they had this problem at all, that they had this evolution problem that they needed to take care of. And unfortunately, they had an SLA in place, and they lost a bit of money on that because the system was down for a while until we could fix it. Yeah, so Java serialization, not the nicest thing to use. Also, in general, it has poor security, so just don't use that. How can you use it in Akka 2.6? You can't. Well, I'm not entirely sure if you can't, but at least you can't use it by default. The new default is now Jackson, and so Jackson has a nice binary serialization format called CBOR, and for most cases that should be enough. The way you wanna, in order to use it, it's pretty simple. You just have to create an interface or a marker trait. Your messages need to implement that interface, and then in configuration, you just wire this up. You say this interface should be using the Jackson CBOR serializer, and that's it. There is also a Jackson JSON serializer if you want to store your things in plain text. Well, yeah, but I'm not sure. I'm not a big fan of text-based formats, so I would always go for the binary version. It's probably faster. One thing I want to mention at this point is it's been very popular to use protocol buffers with Akka for serialization, and protobuf is great, but it also has a price. I mean, protobuf is not, I mean, you have to spend up some time setting it up, getting all the things working, defining messages. And if for the events, for the messages, etc., all of these things that are only going to be used internally inside of the cluster, that are not going to, or cluster or actor system, that are never going to communicate with any outside component, where you don't need cross-language, serialization capabilities, then Jackson is a very good alternative. The performance is good, so I would definitely recommend just looking at this before just going over to protocol buffers, because it's a very decent alternative, and it's there out of the box now, so why not use it? All right, the next anti-pattern. The desire of excessive power caused the angels to fall. I said the quotes were going to get darker here. This is by Francis Bacon, and this anti-pattern is about using Akka remoting directly. This is something where you, I've seen this quite often actually as a question on the forums of the Akka forums, and Stack Overflow, etc. Less so now, but this has been happening quite often, I think. So what happens is people start using Akka, and then in order to deploy actors remotely, the Akka remoting extension. So the problem with the Akka remoting extension is this box down here in this small print here. Remote system must be restarted to be able to establish communication again. So what happens is that if there is a network failure, the remote system is quarantined, and then you have to do all sort of hoops in order to get that to work again. And then at the end of the day, what Akka remote is a way to establish a peer-to-peer communication. But if you want to pair up more than 2 machines, you have to do more work. I spend a bit of time. I'm generally speaking interested in distributed systems, and I spend quite some time reading. Yeah, I just said all of this. Papers on the matter. I tried to fit all of the papers on the topic of group membership here. I gave a talk last year and the year before on that topic, and there is I think I've got failure detectors somewhere here. I don't even remember. So there's failure detectors, dissemination protocols. There is consensus. There's a lot of aspects that you have to think about when you want to build a scalable or stable or maintainable, etc. distributed system. There's many things to think of. And if you're starting with remoting, then you're tossing all of that stuff. You have to build all of that stuff on your own, which is not a good idea, because that's a lot of work. So how can this happen in Akka 2.6? How could you make this mistake? Well, you can't, because the remote watch and deployment of actors is only working if you're using the cluster extension. What's the cluster extension? It's all this free stuff that you get in Akka, and especially the membership layer here, which gives you the platform to say, okay, I've got more than one computer, I've got more than one node, and when I connect them together, they're going to all work together. And all of this quarantine and all of these things, these are things that are solved and implemented. And then, especially on top of that, there is primitives like cluster singleton, cluster sharding, distributed data, on top of which you can build an application. So there is absolutely no need to use Akka remoting directly, remoting is down here. Below membership is down here, but now you can't use it directly anymore. So I think that's quite good to not allow this anymore. Okay. And then for the last of the 6 anti-patterns, there are 2 ways to be fooled. One is to believe what isn't true. The other is to refuse to believe what is true. Very nice quote by Søren Kierkegaard. The 6th anti-pattern is about using auto-downing. So I talked about membership a little bit now in cluster. And what you're trying to do is to give the illusion to your application that there is just one computer that is running everything, and when in fact there are more than one. And this you do with group membership. And where you say all these computers, all these nodes are part of one group. But that's impossible when there are nodes that are suspected of having failed. So it's enough that one node appears to be flaky for this whole thing illusion to fall apart. So it's not a good idea to try to make membership-related decisions when there are processes that are suspected of having crashed from nodes that are suspected of being unavailable. And when I talk to clients, this still happens. This even still happened, not this year yet, but last year I had this. People telling me, oh, you know, network partitions, we never saw this. We didn't have this in our network. Or, you know, we've been running this with AWS for 10 months. We never saw any problem. So, you know, this is not a problem that we have. You know, our network is so great. We have so expensive hardware. It's perfect. And I mean, I get it because it doesn't necessarily happen frequently. But then when it happens, it hits you, and it can be painful especially if you state that's expensive to, or that's important. So you can have problems at the data center level. You can have problems on EC2. There's a lot of micro network parts, very small ones, very subtle ones. Could be in one direction or both. Doesn't need to be EC2. It can be any of the cloud platforms. There can be routing failures. There can be really, and so from time to time you read a headline where, I don't know, some of the big companies had a network partition and everything went down in flames. This happens still to this day. These screenshots are taken from this post here, which I recommend reading. It's called "The Network is Reliable." And so the thing with network partitions is that it's not a matter of if it's going to happen, but when. And so if you leave your system long enough, you will face one. If we go back to Akka now, in Akka cluster, the leader will not be making decisions. So it's not going to let new members in or members leave, so long as there are members that are flagged as unreachable. So what has to happen is that you need to go in there and remove that by the management API by hand, or up until 2.6, you could use the auto downing, resolver, which very naively assumes that if there is a node that's unreachable, we just remove it. And I want to put the emphasis here on this thing in the type, which is do not use. I don't know why, but that's written in the documentation. I think there's even a red box below, or it used to be there when it was there. And people seem to not read this. I've seen it used in production. What's the problem? If I have a cluster here and I have a partition and I use auto downing, this is what it's going, my result is going to be that I will have 2 nodes here and 3 nodes here, and they will both think that they're allowed to be there. And if they continue writing data on a persistent storage, if they can still talk to that persistent storage, we'll have data diverging. This is what we call split brain. And you don't want to get into that. So don't use auto downing, otherwise on the long run you will have a split brain scenario. You can't do this, luckily, in 2.6 anymore because it's gone. Instead, use a proper split brain resolver. I would also call it a split brain preventer, because if you're in split brain, it's already too late. You should prevent that scenario from happening. There is a split brain resolver that Lightbend has built. There are open source implementations, although I've reviewed everything that was there last summer, and back then, I mean, there is none where I would say just go for that. That's fine. It's not. There are issues, and what I've also seen is people build their own, because why not? But honestly, don't do that if you're not ready to spend a lot of time in that and really think it through and test it thoroughly. Don't build an in-house split brain resolver. That's not a good idea. I've seen it happen, and I cannot recommend it. So the last antipattern that I want to talk about, this is number 7. So this is really our last one. It's called being out of touch with the hardware. So you might be familiar with this little platform called Kubernetes, which has taken over the world. I think it's fair to say that Kubernetes has won the ops platform wars, if we can call it like that. Everyone uses Kubernetes. At the same time, there is this quote by Martin Thompson, who is a performance guru, which I really like. Hardware tries so hard to make software fast, and software tries so hard to make hardware slow. This is something we're very much seeing all the time. I mean, I started coding on a ZX81 with 16 kilobytes of memory, and now we have gigabytes of memory, and things are still slow. So let's look at Kubernetes. I've got a Kubernetes. The way it works is you've got pods where you deploy your containers, and then you have a node on which the pods are running. And what you do is you tell Kubernetes, please, this pod needs 2 CPUs. And a CPU is not really the whole CPU, it's just a core. This is why there's a blue arrow here. And this is supposed to be a core, even though I doubt that this chip is a core. You get the idea, you don't get the whole CPU, just a core. Now, that's fine, except that most of the time you will be deploying Kubernetes on top of a cloud platform like AWS, for example. And if you're using AWS, then you get a vCPU, and a vCPU is not really a core, it's a hyperthread of a core. The hyperthread is just this virtual thing where 2 hyperthreads share one core, and if you're in luck, then there won't be a performance penalty. By the way, if you're using not AWS but Google Cloud Platform, it's exactly the same thing. A vCPU is a hardware hyperthread of one of the CPU platforms. So back to this now, where we said we configured Kubernetes with 2 vCPUs. 2 cores, but in fact you have 2 vCPUs, but in reality it's just 1 core. Okay, if you're not lucky, if your application is really busy, then that's what's going to happen. You're not going to see any performance improvement from having hyperthreading, and just hyperthreading illusion vanishes. And this is where we deploy our Akka cluster, or our Akka application, with the thread pool here, which has many threads. And in order to run, this one thread needs to be able to have access to this core. Okay, so this is like a thread pool where we say we have maybe 8 or 16 threads, but in reality we run this on 1 CPU core. And if you thought this was bad enough, it gets even worse, because these are virtual machines. These are not EC2 instances, are not real machines. These are virtual machines, so they share cores, and so they also contend at this level, the hypervisor of the operating system, all of this will be contending for these real cores, and you don't really know and have no control over how fairly things are distributed. And this can be quite problematic if you're not careful, because if I take the extreme example of saying, hey, I'm going to deploy this container with Akka inside of it on a thing with 2 vCPUs, and I don't change the defaults, I still have 16 threads for the default execution context in Akka and 16 threads for the internal dispatcher, then I have 32 threads contending for 1 real core. And that's not even maybe not even a dedicated core, because maybe the hypervisor is still sharing it with someone else, you don't know. Yeah, so that's not good. And that scenario I've seen already increasingly so in the past year, because Kubernetes is really popular and people don't necessarily know about this, especially if you have operations people that are used to Node or services that are, single-threaded essentially, which Akka is definitely not. So yes, you can completely still be out of touch with your hardware in Akka 2.6, and the reason is that Akka can do a lot, but it cannot do magic, and it cannot check what's below the hypervisor. It cannot check, is this a hyperthread? This is something, and even if it could, I would say this is not the way you should. This is the part where you should really think and read the documentation of where you're deploying things, know your infrastructure, and configure things accordingly. Yeah, so that's still there, so be aware of that, I would say. Thank you very much. Yeah, and if there's any questions, I'm happy to answer anything. This is, by the way, a little Akka cluster, and these are cluster shards, and they draw a Christmas tree.
All right, thanks a lot, Manuel. We do have a handful of questions, so let's jump right into them. One of the first ones goes back to your mention of Artery and how Artery has now replaced Netty. How does Artery compare to Netty in this context? Is it that Artery is developed to be more capable of dealing with the specific needs of Akka and Akka streams, or how does that work exactly?
Yeah, so it's built on top of Akka streams. I would say it flows more naturally in the whole philosophy of how Akka is built, and well, I've not been taking I'm not part of the Akka team. I have not built this, but I would say that essentially I think the main reason is that there is much more control over how it works, and bugs in Netty that were fixed or appeared, etc., were harder to. Certainly, one reason probably was that it's harder to fix things faster, but also overall. And if I'm not mistaken, one of the first things support there was for the Iron cluster or the Iron transport, which is a very high performance protocol, and there has been a lot of emphasis on performance that's been done in there, which I think has flown into Artery, and yeah, this is what I would say it is. I wouldn't need to ask someone from the Akka team to know all of the details, but what I've observed is that it's more stable, actually. That's something I've seen on clusters that have run larger size clusters.
Okay, so essentially it comes down to the Akka team and Akka community being able to kind of actively tweak and optimize this transport layer.
That's only one
direct control. Mm-hmm.
Yeah, probably not the only one, but definitely one of them, I would think.
All right. Another question is about blocking.
Yes.
There's a couple questions about that. I'll try to kind of wrap them into a meta question. So when we're working with Akka and we have to connect to a, let's say, non-reactive, non-asynchronous database, such as using JDBC JDBC, for example, is blocking when issuing MySQL calls.
Yeah.
So how do you avoid this conundrum? Do you need to use a different database? What if you can't? What are some of the paths forward when you're working with non-reactive, asynchronous technologies?
Yeah, so with databases, this is a particular subset, and it's well understood. For this, it's completely legitimate to use a dedicated thread pool, and even the size of the thread pool can be tailored to how, to your database, how that is configured, how the hardware there is, or there is. I actually wrote an article on this a while back, which I can later send you a link to. But it boils down to using a custom dispatcher for that, and a small thing to enable asynchronous integration with it, either through completion stages or through Scala futures, and then that's fine. the other thing I think that is worth mentioning at this point, there is an asynchronous variant of the JDBC standard in the works, as far as I know. I've not been following it lately, but it's definitely out there. So chances are we're going to see that even for all of the existing databases out there that use JDBC. Yeah.
Okay, cool. Thanks. Let's see. There's a question about message size when in terms of sending messages to actors. Is there an anti-pattern that's kind of difficult to identify in terms of the size of the messages? Is there a problem with very large messages, and how does Akka handle that?
Yeah, so I don't send megabytes of messages. So the messages in Akka between actors are meant to be sort of data or logic that's shouldn't go much more than a few kilobytes. Or you can go further, then you have to start tweaking things. But if you go and if you're going, I don't know what the question. If the question is about like things like sending images or binary data, I would not do that using typical actor-to-actor communication. I would actually go and use something dedicated, a dedicated thing like gRPC or something where you really send binary data over a wire and using a protocol or transport designed for that. I wouldn't be using the typical actor-to-actor communication for that. I would just send metadata to the actor and the binary data in another channel. That's how I would approach that. Yeah.
Is this something that one could use Akka streams for?
Oh, let me think. You would, yeah, you could use Akka streams, and you just need to chunk up your data in that regard. But I would definitely point towards Akka gRPC, which I think is, if I'm not mistaken, there is a streaming. Yeah, there is Akka streams below this actually, and this is how I would go for streaming large amounts of data.
Okay. I mentioned Akka streams because one of our final questions that we have time for today is about how Akka streams plays with all of these new features in Akka 2.6. So what can you tell us about Akka streams?
There is an adapter for Akka streams to Actor to the Typed API that I know of. But because basically that's the in terms of typed is the actor realm, and then the other completely different API is the streams one, where it's a different model in one way. And there is a bridge between these two things with Actor F-Sync, I think it's called, and well, the syncs and the opposite of syncs. Source, yes, thank you. Source and sync, which are ActorRef aware, and there is an adapter for the typed variant. So that's still there. That can completely be done. I haven't looked into the. There are quite a few improvements as well in terms of streams in the 2.6 release overall. I have to admit I haven't zoomed into that aspect there yet, but yeah, I would just check the release notes to see what's really been happening on that level.
Okay, so people can find out about you at manuel.bernhardt.io. They can also find you on Twitter at lmanu. Mm-hmm. And yeah, that's great. So, well, Manuel, this was an excellent talk. I think it really framed things nicely for people that wanted to learn more about how they can do things a little differently in a much more guided and let's say human readable way with Akka 2.6. one real final note, in terms of upgrading to Akka 2.6, you know, that's supposed to be a somewhat painless process, but
Yeah.
what are some of the things that final notes you can give about, you know, if you're using Akka 2.5 or earlier or something, you know, how simple is it to start using at least some elements of Akka 2.6 without too much pain?
So if you can just update and you don't have, on the operational side of things, you can switch your application over. So the one thing I would say, the first things to look into with Akka Typed is just look into Akka Typed. There are adapters, or well, from Akka Classic to Akka Typed, and that's one thing I would look into, because you can integrate that into an existing system. So you could start writing a new actor with Akka Typed and plug it into the existing actor system, and then bit by bit, if you want to move to Akka Typed in that regard.
So basically, you can just add the new typed actors into your existing actor system, and there won't be any problems. Well, ideally.
Yeah, you can. Yeah, there is a bit of boilerplate you have to do just to plug it together, but you can start using. So if you're extending the system, you can do that with typed and start and use that as a way to start typing the whole thing. And you don't. So it's not a big bang kind of thing. So it's a gradual approach. Yeah, that's so that's one of the first things I would look into, because I think that the typed API is really the way forward. And even if you don't want to do that, and if you can just take a bit of time, go through the migration guide and switch, you get a lot of things out of the box for free. As I mentioned, Artery, you get some things disabled that you shouldn't be allowed to do. And if you haven't done anything exotic, that will be mainly painless. So that's nice.
And type safety.
And type safety, yes.
Yeah. All right. Well, Manuel, thank you so much for your time today. This was an excellent talk. To our attendees and audience, thank you for joining us today. If you are connected with a Lightbend representative and you have some questions about Akka 2.6, then go ahead and reach out to them. They'll be happy to point you in the right direction. And I guess that's all we have for today. So we'll see you next time. Thanks, everybody. Bye-bye.